So we have calculated the value of Fr, but what is the point of action? On which point is our Fr acting on? Is it on the centroid of the board? Well, I think not. Why? Because you can see the pressure at the lower point of the board is higher than that of a upper point of the board, right? Which means the Fr, we would expect that to be acting on a point that is slightly lower than the middle, which is the centroid, right? So how do we calculate that? By how much amount is the Fr, the point of action of Fr, lower than the centroid? Well, we need to bear in mind that what is a resultant force? A resultant force, first, it should be the sum of the forces we want to calculate their resultant force, right? This thing we have achieved, but there's yet another thing, which is the what caused by the resultant force should be equal to the other forces. The moment caused by the resultant force should be equal to the sum of the moments of all the other forces, which is the moment caused by our small pressures, right? So we will make them equal. Fr, we need to point out where the what is the lever, right? Let's pick this point, y equals to 0, to be our fulcrum. So let's denote the y coordinate of our point of action of Fr to be yr. Then obviously the moment caused by Fr with respect to this fulcrum is Fr times yr. This thing should equal to the sum of moments caused by these small pressures, which is, well, we'll take out one slice of y at a time, okay? So this is our board. We take out one slice of y value at a time. So let's say at y, at a y coordinate of y, what is the moment caused by the pressure acting on it? It should be Py, right? The forces, the pressure acting on here is Py, and we need to times the multiply the Py by the lever, which is the y coordinate here, because we are taking the moment according to this point. Py times y. We need to times the width, right? But we see if all the y slices are accumulated, then we are just integrating this thing on the whole area, right? So we can write it this way. Py times y, we integrate this thing on the whole area of our board. We know what's Py, we can write it out. Py is just gamma times sine theta y squared dA, right? Here we have a y, but in Py we have another y, so we end up with this thing. Gamma sine theta is a constant. We can pull this thing out. Gamma sine theta, the integration of y squared on the area of the board, and this thing has a name. Do you know what's that? It's called the second moment of inertia. Second moment of inertia. We denote that by IXX. Okay? So if we know this thing is IXX, then we can write this thing as gamma times sine theta IXX, right? So this will give us an expression of YR. YR is just this thing over FR. FR we know is this thing, right? So maybe we'll drop the arrow and just calculate the value. Gamma sine theta IXX over this thing, PCA, right? PCA is the value of FR over FR. Okay, so actually this is our result. But we can process this thing a little. Because the IXX we calculated here is regarding which point? This point, y equals to 0, right? This is a random point as far as this board can see, right? So we know in mechanics books or formulas, many of the times the IXX value of various shapes, rectangle, circle, you name it, are given. But they are all given in a form of IXXC, let's say, IXXC, which is taking the IXX respect to the shape's centroid, not some random point outside of the shape. Okay, so maybe we can use the formula to transfer this IXX in terms of IXXC. Okay, I'll tell you the formula. It's IXX equals to IXXC. The formula, the moment of inertia regarding some point is equal to the moment of inertia regarding to the shape's centroid plus A times YC squared. YC, you know what is YC, right? YC is the point we are speaking about. Let's say the distance from the point we are speaking about to our centroid. This thing is called YC, and A, of course, is the area of the shape. IXX equals to IXXC plus A times YC squared. So if we plug this formula into this thing, we get our final expression, which is PCA. Well, we know what is PC, right? PC is gamma sine theta YC. I don't need to write that out, right? We have spoken about that before. So here we are left with YC in the denominator, and here gamma sine theta are cancelled. We only have IXX on the numerator, which we can decompose into IXXC plus AYC squared. AYC squared plus IXXC. And we notice that this can be divided into two parts. One part is AYC squared over YCA, which is just YC, plus the second part, IXXC over YCA, right? So what have we learned? YR is always bigger than YC, right? IXX, the moment of inertia, is always, you see the square here. So it will always be a non-negative value, or a positive value, I can in fact say. So we see YR is always bigger than YC, which is in accordance with our intuition before, right? I told you that since the pressure down here is a little bigger than the pressure up here, then the resultant force should be acting at a point that is lower than the centroid.